Thank you very much for inviting me. And thank you to Peter for not only the release, but many years of releases and releases and releases, and for covering a good deal of the background for what I wanted to talk about. The idea that I thought that might be useful would be to give a case study of one particular very small discipline and how the arrival of R made it possible to do things that we couldn't do before. So the materials for what I'm talking about are here, so that the slides are here. If things go wrong, then you can watch them yourselves. There's also a script giving you the 2020 version of a class in 2000. So I'm reproducing what we were doing in classes with students 20 years ago. And I thought I'd give you also a slight flavor of where things started. I joined the R Alpha list at the end of 1996. And Robert Gentleman in January 1997 asked people on the list to reply with some comments on who you are, what your affiliation is, and what you're using R for. So that this is from my email system at work. And it says that what the intention was in early 1997 was to examine using R for spatial and possibly spatial statistics, geostatistics, to use in addition to S+, and possibly XLisp, Stat, and OX. I also had some code in awk, but it was difficult to use that with students. And I think the thanks for some very good work so far still applies. So that was the situation as it was when the door started opening. 20 years ago, as Peter said, that it was difficult to do stuff. It was even harder to do spatial stuff. Many of the software applications were costly. Not only were they closed source, so we couldn't see how the methods were implemented, but they were also expensive. So it was really difficult for universities to provide students with access to up-to-date software. We can't say what has actually happened in relation to the use of R for spatial data analysis, because obviously we don't monitor these kinds of things. But as you'll see as we go on, some things have obviously happened. One of the things that we can see very clearly looking at pagerank analyses of CRAN packages is that there are a lot of things going on there, and how many package relationships then multiply out into uses in research labs, in companies, and in universities, it's impossible to tell. But given correspondence and contacts with users, then we know that there are quite a lot of people out there somewhere. One of the things that this leads to is the stress on maintenance and backwards compatibility, but also to try to open doors for new methods of analysis as they arise. Over the last 4 or 5 years, we've had access to web mapping. So this is a very simple script which you can run now, which downloads the light rail city and the light rail system for the city of Bergen, where I work and live, and which certainly 20 years ago there wasn't OpenStreetMap. There weren't the facilities. Getting hold of digital maps in general was very hard. GPS only arrived with civilian access to relatively high precision GPS in 2000, so that we just didn't have access to digital maps at all. This script runs as a downloading the data from OpenStreetMap in a couple of seconds. I won't demonstrate it, but the code is uploaded. Of course, with data, and being a geographer, one always looks at the data. In this case, there were two contributors, one of which called the construction of the light rail system light rail, and somebody else who called it trams, that you've actually got to download twice to get the one which is called tram and the one which is called light rail, put them together, and then using the SF package, you can pass things straight through to map view and generate a map. Even more complicated things, city bikes. Copenhagen also has city bikes, so that this is using CSV files, which I could also download in a script for city bikes in Bergen. This is for the accumulated list of city bikes through the journeys by city bikes from the beginning to very recently, middle of February. And using the ST-planar package, then we can firstly find out what the origin destination links were. This is the left-hand diagram, again in a web map. And we can also route them to a designated cycle route. So we can find out what the loading on a particular cycle route would be. Actually, if you looked at the data in a little bit more careful way, you'd see that the data are simply recording where the bike was checked out and where the bike was checked in. And we don't actually know where it went, but we know that it must have gone at least from this point to this point, but we don't know whether it went by a circular route or whether it, and we can't show an origin destination line for bikes which were checked out of and checked into the same station, so that they're dropped out. But all of these things we can do now, and a lot of this has been happening very, very recently, so that much of the pressure now is on keeping up with web mapping and for making the results of analyses available in this kind of interactive form. If we dial back to 20 years ago, there were probably a number of us around the world trying to teach courses in spatial data analysis, and we found that we were limited by access to software. The geographical information systems were the typical software that we used for teaching, but many of them were also very expensive. Some universities had site licenses, other universities didn't have site licenses, and it was generally fairly messy. It was difficult to program. In the market leader ArcInfo, by 2000, they were the market leader. You could write in the advanced macro language or in Avenue or Visual Basic later on for ArcGIS in the 2000s, in the noughties. Now, I have a postcard by my desktop sent by a French ecologist from Tibet in 2005. And there they were able to run on a laptop without a dongle. Does anybody remember what dongles were? Okay, so that you need, if you were running licensed software, you had to have a dongle probably on the parallel port of your laptop. Your laptop doesn't have a parallel port anymore, but then they did. And it was expensive, it was costly, it was difficult, and laptops actually found it quite difficult to use the software which was designed for desktops or the multi-user systems. So that he could sit with his students on an island in a river in Tibet, making samples so that they could generate the samples using the positions, they could observe them, and they could enter the data, and they could make a map of it. Very simple map, not a web map, but they could do their ecology with less hassle, and this seems to have mattered. These are things which Peter's already talked about. In relation to spatial data analysis, spatial statistics, Kawushny and others at Insightful had published an S+ spatial stats module. I think it was launched in Oxford in 1996. And I was at that meeting, and there were a number of other meetings among people doing spatial data analysis. That one was in Leicester also in 1996. You'll see some of my names in the references, but this is to allow people to get back to me if they find errors. I'm not promoting myself. I'm just simply pointing out that this is the reference you need to go to if you find something that I've said is really stupid. So you can find out why that was. I don't deny that probably there were things that were written both many years ago and today, which are completely questionable. A lot of the work was begun by Albrecht Gebhard in Klagenfurt, because he also needed to teach, and his lab didn't have software that he could use for teaching, in his case mostly geostatistics. And as soon as the package mechanism matured, then it was possible to port software which had been used in S+, and which people were using for teaching, but could be used with R, where you didn't need to pay the license costs, and where you could extend it. It was easier to move forward. That isn't to deny that from S3, the S+ community was vibrant. There were lots and lots of people doing very interesting work and communicating about it, and the mailing list was really interesting. But much of that energy subsequently moved over towards us. The porting from things which run under S+ to R was important. So that among the packages that Albrecht ported fairly early on was TriPack, Akima, then Ash, SGeostat, and so on. And he also helped with the porting of the spatial package from Mars. Also, at this period, the CRAN administrators were very, very helpful, so that they would provide hand-holding guidance to those of us who were moving in these kinds of directions. And then we summed it up, Albrecht and I summed it up at a conference where I'll try not to do today what we did there. We were given a 20-minute slot and we used 50. Wouldn't go, but actually the people listening to us, they said, the chairman had he just had red cards and stuff, but they said, this is interesting, we want to hear you complete what you're talking about, because you've been through the different bits of spatial statistics, the point processes, the geostatistics, the aerial stuff, and we want to hear you get to the end, and where can we get the code? Was what we were interested in. What I was teaching was using a book by Bailey and Gattrell, which had a diskette. So there was their own produced software on a diskette, which couldn't be run under Windows. It could only be run under DOS, because it had its own graphics interface. So we got a bit stuck when the university computer lab that we were using in our department went over to using Windows, because we couldn't use the software that we had been using previously. The picture is of the CD that I got when I joined became an ordinary member of the foundation in 2003. The kinds of books we were using was one in statistical geography, which is a sociology book from 1961, which was pointing out the problems that you have when you segment data or aggregate data into area units. It's followed up by Cliff and Ord. You can hardly see the white text at the top, which says spatial autocorrelation. And Cliff and Ord then produced a second edition called Spatial Processes in 81. Brian Ripley's book on spatial statistics in 1981. This is a reprint, so it doesn't have the same cover as the original one. Bob Haining's book on spatial data analysis from 1990, and Noel Cressey's spatial statistics for spatial data from 1991. This is the corrected edition from 1993. They divided, certainly Cressey treated spatial statistics as being point processes, being geostatistics, and being lattice or aerial data. And so that the example that I'll be giving you is from a class in 2000 using R to run these kinds of things. So that, say, working on someone who taught me at Cambridge, Leslie Heppel. This is an article of his from 1976. So how do you estimate a model taking account of the spatial autocorrelation, possibly in the residuals of the spatial autocorrelation? And I had a number of other attempts to implement these kinds of things. So I'll start off showing you the 2020 version. And I won't go into any of the detail because at a certain point you'll get really bored by my giving you a talk about something you don't need to know about and jump out of that. But anyway, so we have here a geopackage. In this case, it's a shapefile, which is in a package called SPData, which is a collection of data sets for spatial data collated by Jakob Novosad. And it was prepared mostly in connection with a recent book called Geocomputation with R by Novosad, or by Robin Lovelace Novosad and Jakob Novosad and Janez Munchel. Okay, so there are packages some of which have arrived recently. SF has arrived fairly recently. We used SP for quite a long time. This is just reading in a file in a format which could be read by a geographical information system and which has both the geometries and the data attached to each of the observations. The data file itself was built by Michael Tiefelsdorf. And now the idea was to find out which of the counties of the Irish Republic were neighbors of each other. In early work, then you didn't have the digital boundaries, so you couldn't use the digital boundaries here in the function poly to NB to grab the neighbors. You had to look at the map and note it down on a piece of paper, which county is the neighbor of which, and go from there. And that will be the place we'll go in a moment. There are a number of standard tests, so that Gear is C, Moran's I. They're from the late 40s, early 50s. The idea being to find out how likely it is that neighbors are more similar to each other than non-neighbors. So then in the Geary test, then you're looking at where the spatial weights here, as if you're not a neighbor, the spatial weight is 0. If you are a neighbor, the spatial weight is 1 or some positive number. So that obviously the product here, including the Wij's, will be 0 if you're not a neighbor, and whatever it would have been, so that the weight times in this case, the product, or the weight times the squared difference, if you are a neighbor. So you're finding out what difference does it make being a neighbor. And then there are a number of standard tests. These are the current implementations which have actually been around for more or less 18 years. But at this stage, I'm going to try and be brave and go here and fire up the R for Windows 100 from today, 20 years ago. So I'm now running on the code as it was 20 years ago, and we'll try to show you what kinds of things we were doing with the students. Whether they enjoyed it or not, don't really know. Some of them learned some stuff. Some of them gone on to do work in GIS, but with a sensitivity for the fact that you shouldn't infer, say, you've got two variables measured on aerial aggregates, you shouldn't infer from the correlation between them or from a regression model without thinking. So we have a working package mechanism. Making Windows packages at the time was okay. It worked. It wasn't quite as you do it nowadays, but there were no R tools. But we can load the data. We can create the object here, so that if I say a list of weights, it's a list of the things you would need. It's in the sparse representation. Essentially, the representation is almost the same as the one that I wrote in Fortran in 1974, but hey, sparse is sparse. So you don't really want to have dense matrices when you can use sparse. So now we have what we need. We have a data frame with the data for Ireland in it. We have two variables that were used in Cliff and Ord's in Cliff and Ord's 73 book, which was based on work by O'Sullivan from the late 60s, which was that own consumption on farms in counties in Ireland was related to road accessibility, so that farms which had better accessibility to urban markets wouldn't consume as much of what they produced as farms which had poor road access. Poor road access is that the accumulated count of miles to urban markets is larger, and an own consumption is then a proportion of how much consumption of a farm is consumed on the farm itself. Now, in the exercises in Cliff and Ord, they were interested in looking at the spatial autocorrelation between the counties in Ireland in own consumption. And using the Moran test, the values of the Moran test are difficult to interpret. They're not quite like a correlation coefficient. The Moran's I is very like the Durbin-Watson test for time series and comes from about the same time period. But the standard deviates are quite large. And here the implementation in the package which I wrote for the students at the time gives us, for Moran's I, with row standardized spatial weights, 0.71282. And if we go back here, we've got, oops, I'm not sure that I can paint on this, 0.71282. So I wouldn't be terribly impressed by that myself. So it's not a miracle that they still get the same result, because it's largely actually the same code. It's just that it's been presented in a different way over time. The same kinds of things then extend to plots and to running spatial regressions and so on and so on. So that we could test regression residuals now, and this one, yes. So that this is a second test. We can test the regression residuals. Oops. Controlling figures gets harder. So we fitted the regression model. The LM code in R is more or less the same, and the Lagrange multiplier tests are more or less the same. You won't want to hear me give a talk about what the Lagrange multiplier tests are and things like that, but there's Anil Berra, Luke Anselin, econometricians, and so on. So the flexibility which implementing in R gave us helped a great deal. So that this is then the rest of the spiel. It's what I've lived for 40 years, so okay, so you don't need to know that. But what then happened in the area was learning S3 classes. Learning S3 classes meant that when I was working with the students originally, as you could see, the functions were simply printing out the results as they came, which was what we'd always done before, so that you wrote a function and the function printed out its own results rather than returning an object, which then had a summary method and a print method and a plot method and so on and so forth. One of these things led to questioning how you would do predictions from a fitted spatial regression model. So maximum likelihood spatial regression model, how would you do predictions? And this then led to a Google Summer of Coding project, and which implemented the Goulard et al. Article on this. It turns out that it's quite complicated, but it also led to the understanding that the effects or the impacts of the spatial regression models are not as simple as we thought they were 20 years ago or 30 years ago. And in work done by, in particular by Collegian, by Jim Lesage and others, so that trying to think aloud about which methods you should have for a fitted model object. So you'd have a summary method, you could have a plot method, but you should have a predict method for a fitted spatial regression. This wasn't in the S plus module, that kind of thing. So we're trying to think. Then there were contacts from other people as well, from Lance Waller and Carol Gotway, who were writing a book on spatial data for public health. And they said, okay, but you're looking at things not even with one eye, but you're looking at things with one eye through one tunnel. You've got to broaden your view of how we do spatial regression to include all of the geographers and the economists and the sociologists were using one understanding of how you modeled spatial dependence, and epidemiologists were using another one. So we were using SARS and they were using CARS. And there's a nice paper from 1997 called Fast CARS. But we weren't doing CARS, we were doing SARS. But in Waller and Gotway's book, they did SARS and CARS, so that they said, okay, so that raise your game, implement the CARS. And so there was a lot of interaction between different people implementing different methods, leading to substantially better understanding of the underlying sort of what's going on, the data generating processes. And what I've been doing more recently is working on comparisons very often across platforms to try to find things out about what's going on. So that the range of applications has been really very surprising. Ecology, environmental data analysis, epidemiology, and which we found really odd, phytogenetics, who also use spatial methods, in particular what's close to what, in their work, which we hadn't thought of, because you can't really see phytogenetics on a map. But they're also the relative positions of things. So where did we get with developing packages? One of the things that we realized very early on was that it would be very helpful to establish a system of classes for containers for spatial data. So we could see the spatial data sort of out there in different formats, but when it was used in different packages in R for 20 years ago, like Splanks in spatial SGeostat, they were all representing objects with their geographical coordinates, but they were putting the coordinates, putting the geometries in different ways. Some of them were using data frames, some of them were not using data frames, some of them using lists and putting the different bits and pieces in different bits of lists. So you needed to coerce from one representation to another, to a third, to a fourth, to a fifth. And so I wrote back to an email from Barry Rowlingston in Lancaster in 1998. Users maybe, but for users, maybe the objects ought to appear to be the same. Then work went on. Subsequently, I did some work on GIS and went to DSC in March 2001 in Vienna, which was encouraging, and I got a lot of encouragement from people there. Talking to Luke Anselin, whose name I've already mentioned, who was very helpful, and some workshops and stuff. So that talking to other people, it seemed sensible in 2002 to try to coordinate things, to get people together. So we had a workshop, about 10 people in Vienna in March 2003, which was the final big DSC before it moved on to use R. And Edsa wrote in, and again, I can't highlight the text here. Edsa wrote in November 2002, I wonder whether I should start writing S classes. I'm afraid I should. And since then, he's been very busy writing and refining classes for spatial data and others. And Virgilio Gomez Rubio was also very active. So that there were other people who corresponded with us who weren't able to be present. So Nicola Wynne-Koch wrote, I was looking all over the DSC material, especially the spatial stuff. I did notice after looking through people's packages that there's a lot of duplication of effort. My suggestion is that we set up a repository for spatial packages similar to Bioconductor, where we have a base spatial package that has S4-based methods and classes that are efficient and general. Okay, so that was the mandate for developing SP. We set up a SourceForge repo, RSIC geo mailing list, and that was where we went. And surprisingly, we thought we got as far as a book in 2008, and we thought, well, probably that's about where it finishes. There are about a dozen packages, maybe 20, that use these classes, and that will be more or less where things stop. We didn't sort of try to make other people use the classes we were using. That wasn't sensible or useful. SpatStat never did, but we coerced backwards and forwards with SpatStat. We managed to integrate ways of reading and writing files of geographical data using rGoodle and so on. rGeos was added later. Now the shock was we realized by the second edition of our book in 2013 that the number of packages which were depending on SP had rather increased, because we had in the first edition in 2008 a really nice little tree showing the reverse dependencies from SP. We would need to have a sort of fold out, 4 times fold out, to get the figure legible in 2013. In 2014, Andre de Vries did a PageRank graph of CRAN packages, and this is then a view of the 4th inclusive bioconductor CRAN cluster, where SP is there. Then you see that APE, which is the phylogenetics, is also, so it interconnects with many of these packages. SF is not in this yet because it's relatively fresh, 2016, 2017, and is a re-implementation of many of the things that we've already been doing. The raster package is also there. It's being redeveloped as the Terra package for handling raster data. In SP, we had what we called a spatial grid for handling sort of image files like satellite images. Regrettably, it hasn't been written up. It would have been nice if there was a raster book as well, but there isn't. Some ways forward, we talked among the people who felt responsible for maintaining stuff. We talked after completing a JSS special issue in 2015, which was quite a lot of work, getting 20-something papers into a Journal of Statistical Software special issue. And we said, okay, so we need to re-implement SP. We call it SF, simple features. And the STARS package then handles spatiotemporal arrays. So that these are much newer representations, ones which weren't available when we were doing the work on SP 17, 18 years ago, 16, 17 years ago. And then there's newer work also in STARS and Google Cubes, which does work on satellite imagery on the server, so in the cloud. So what you do locally is to commit a workflow to the cloud, which is then processed on lots of nodes, and you only bring down the results that you actually need. So there's a lot of activity there. But it's more or less stitched up, joined up, so that we know more or less what's going on. For visualization, it's the excellent TMAP package, MapView for interactive cartography, and the cartography package, which is also very good for doing these kinds of things. Now, package dependencies started to weigh on us because as everybody who submits packages to CRAN knows and has packages which have reverse dependencies, that running the reverse dependencies takes time, so that my desktop is now mostly used for that. So all of the cores on the desktop get used for running because changes are coming. So give you some tabulation so that if we take the recursive, just the depends and the imports, then for only SP packages, then we're at 1167. And 50 which are only SP, and then there are another 211 which use both of the packages because they're starting to migrate to SF. So the process at the moment is trying to migrate towards SF. We still sleep at night. It's like everybody else who has reverse dependency issues. The feeling that we have changes we need to make. Things are going to be better, but we're going to inflict pain like the was not pain this one, because this is bringing in all of CRAN. So we're not going there. So where is the pain coming from at the moment? This is then the extra 5 minutes. So what happens if you build R packages depending on external software? We did this because both for our Google, using Google, I pronounce it not GDAL, but Google, and GEOS, then whenever the external software changes, iterates, then there are consequences for our packages, and then there are consequences for all the packages which use our packages. And this applies just as much to the SP-based as the SF-based workflows. This is a picture of the SF workflows where you can see the dependency on Google and Proj and GEOS. So changes occur in the upstream external software, and so the packages, the R packages, need to adapt, and sometimes the changes which occur are breaking. So that I run the code from our book nightly for both editions, so we know when something has gone badly wrong, because we can't rerun things that we wrote 15 years ago. And sometimes the changes are caught on CRAN because the CRAN team run on all of the other packages which were not running, then they also catch things which change when upstream happens. Now, the Danish, or two Danes, developers of Proj, said that, okay, this is Knudsen and Evers, said 3 years ago, the world has changed, and in particular, there have been sufficient tectonic shifts for the model of the shape of the world, known as the World Geodetic System of 1984, to become partly outdated. In parts of the world which move around more than others, it's become very outdated. In other parts of the world, it's less outdated, but even so, it was a compromise made by a committee. So it wasn't really a picture of the geodetic reality. So Proj risked ceasing to be fit for purpose for all of the open source packages, well, software which uses it, which is an awful lot. So more or less everything that you see, from OpenStreetMap to Google. Google uses their own stuff too. So that Proj started being updated, not to use the representation that it had used for geographical coordinates, but to use a newer representation which they felt was more robust. That meant that the representation we'd used internally in SF and SP is going to degrade seriously. And the kinds of things which are happening, and the example here is from the John Snow Broad Street cholera data set. Those of you who are biostatisticians or epidemiologists will know about the cholera outbreak in 1854 in Soho, and that John Snow removed the handle from the pump in Broad Street because he knew, although it wasn't the accepted medical knowledge, that cholera was transferred from dirty water. So the people drinking water which was polluted would very likely become ill. And so he disabled the pump to get hold of that. So the Broad Street pump is really important. It's been used a lot in teaching, in textbooks, and in propagating geographical information. So we have a file here in the British National Grid projected coordinate reference system. And we can read it in both in the SP workflow and the SF workflow. And we can show that with the previous versions of Proj and Google, then there's a pump symbol on OpenStreetMap, which is now more or less covered up by a little blue dot, which is the position we have from the file. In order to present something on a web map, you need to take it from its original coordinate reference system to transform it to World Geodetic System in 1984, and it's then transformed again, which is a simple operation done internally by Leaflet, to Web Mercator. So that in order to get the dot into the right place, it has to go through at least one important transformation step. And if the metadata attached to the point to say what its coordinate reference system is not understood correctly, it will end up somewhere else. So that once Proj and Google updated, without having updated our stuff, so running the same versions of SP, R Google, and SF, then we got it offset by 125 meters. So that instead of saying that John Snow took the handle off the pump in Broad Street, we'd have to change it and say, no, sorry, the pump must have been in Ingestree Place. It wasn't in Broad Street. So that since we realized that this was happening, which we realized during last summer, we hadn't thought it was going to happen, and it did happen. Edster and I have been scrambling violently to get things sorted out, so that if we do not use the new modern representation, text representation of the coordinate reference system, with SP we still get the displacement. But we've now sorted it. Now all we have to do is to persuade the 1300 something package people to look through their code and sort things out. Sorry, that's what life does at the moment. So we're fixing things, getting them done, without being able to interact. So this is now the today version of how R helps in working with software like this, is that Proj 700 release candidate 1 came out 2 weeks ago, and I've managed to get a patch into it, and it will now be released as Proj 700. But because we work closely with things, then we're able to feed back experiences, mostly exposing functions in the API, which we need in order to provide information for our users. Whether our users are on receive with relation to the information is, of course, a completely different thing. I think we'll see the same thing with the changes of strings as factors. It would take some time before people realize that the world is changing. So we have SF, we have stars. All of them seem to be developing positively, a lot of movement. We need people to move away from the legacy shapefile format, although people still talk about shapefiles. It needs to be geopackaged, and so on and so forth. A possible takeaway for those of you who do not do spatial data, or do not think that you do spatial data but do machine learning, is work very recently. Again, this is enabled by having classes for spatial data and R and machine learning all in the same thing, so that there are useful papers by Patrick Schatz in relation to MLR and MLR3 and the block CV package for showing how you can handle the existence of spatial autocorrelation in data sets where you're subsetting to get a training set. And if there is spatial autocorrelation, obviously, if the test set and the training set are close to one another, the test set will not be independent of the training set, so that there are some references there. In the PDF, there's aftermatter. All of the references are there, and many of them have links. So that for those of you who do machine learning, then so you have at least something to take away from this talk. I'll conclude there, which takes me more or less up to the line.
Yeah. We have time for 1 or 2 questions for Roger. So, anyone? Yeah.
By chance, I get maybe once and a half year to go back and revisit SF and SP to build a model for some client, and I tend to find myself both using SF and SP, but I'm like falling between 2 chairs. I can't decide which one I want to use. And do you have some advice today? Would you say just go with SF and try to make as much as you could there, or are they both important to have at the same time and kind of have both object representations?
Depending on how much time you have at your disposal, provide patches, diffs, or if the packages you're using have pull requests. For the other package, so if there's a package using the SP workflow that you wish to suggest that they move towards SF, then try to be proactive in respect to them. So say that, look, this would be easier to do if you did this. Many of the package maintainers have day jobs, so that the table that I showed, there is probably more migration than we were afraid would happen. We were afraid that very little would happen. Some is happening, and some packages now can do both, so that they'll coerce to SF internally, or coerce from SP to SF. So TMAP does this, so that if it gets a spatial object, then it will coerce it to an SF object internally. But I think that people who see the need to reach out to the maintainers of those packages, and if necessary, point them in the right direction. So give them a helping hand. Sometimes they wanted to make a move, but haven't got there. So in general, SF is ETSA is okay, 15 or so years younger than I am. So the point that you made is I'll be retiring next year. So my university will stop paying me anyway. So the point you made is very relevant. So that on that basis and single points of failure and things like that, then SF is a safer deal. But we need to try to help get the packages which are using SF, using SP workflows to think about moving. And the big problem here is raster, because raster depends on SP classes. And Robert Heemans also has a lot to do and has different ideas for how to develop this, so that this is why the Terra package has just been submitted to CRAN. But once again, he still needs to deal with people who are in a raster SP workflow. If there were only 5 of them, then we'd do a teleconference and sort it out. But if you're over 1,000, it gets a bit crowded on screen to see all the faces. So, but it's that is something we've been thinking about for 4 years. How we can move people on.